In many applications of calculus, we encounter situations in which there are variables, say x and y, that satisfy some relationship over interval of time t. We usually have some knowledge on the rate of change of one of these variables with respect to time, and we wish to find the rate of change with respect to time of the other variables. These problems are called related rate problems and are the focus of study in this section. Here is an example of one of the most common related rate problems. As you can see, there is a ladder 20 feet long resting up against a building of unknown height y. It is also unknown length x away from the building. You can see this makes a right triangle. We are given that a ladder 20 feet long leads against the wall of a vertical building. If the bottom of the ladder slides away from the building horizontally at a rate of 2 feet per second, how fast is the ladder sliding down the building when the top of the ladder, how fast is it sliding down when the top of the ladder is 12 feet above the ground? Now, the first step in any related problem is to get organized and think about all the things that you have, what was given to you, draw a picture, and then write an equation that goes with it. For example, we're given that the rate that the bottom of the ladder slides away from the building is 2 feet per second. So we're going to call that dx dt is 2. And then we want to know how fast the ladder is sliding down. So what we want to find out is dy dt. So we're going to put a question mark here. And that is when y equals 12. Now that we're organized, we need to write an equation. Now you'll recall from the previous slide that the ladder leaning against the building made a right triangle, and we know the formula for area of a right triangle, or the formula for how the sides of a right triangle are related are a squared plus b squared equals c squared. But in this case, we're not going to call it that. We're going to call it x squared plus y squared equals, well, what it equals is the length of the ladder, which is 20 squared. So now we differentiate to find the rates, because what we want is a dx and a dy, and all we have right now is an x and a y. So we get 2x plus 2x times dx dt plus 2y times dy dt, can't forget the inside, equals 0. We can then plug our known numbers in. We know that 2x dx dt is 2, and that's going to equal negative 2 times y is 12, and what do we want is dy dt. Now we have two unknowns, dy dt, which is what we want, and x, which we can solve using this equation up here. We know that they're always going to be related. Therefore, if we plug in the 12 into this equation, we can solve for x. X squared equals x squared plus 12 squared equals 20 squared. And we find that x is 16. Now, going back here, we can plug in that number, so 2 times 16 times 2 equals negative 2 times 12 times dy dt, which is the rate that we want. We know that 2 times 16 is 32, multiplied by 2 is 64, and we get negative 24 dy dt. Or dy dt equals negative 2.66 feet per second.